Hello students, welcome back to my lectures of class 11 physics. We are studying our chapter motion in a plane, and here we are studying the topic projectile given angular projection. Here we have studied many points related to this topic, and here we have the fifth point, that is the velocity of projectile at any instant. मतलब हमारे पास कोई भी एक प्रोजेक्टाइल है जिसको हमने किसी एंगल पर थ्रो किया है, एंड वी हैव टू फाइंड द वेलोसिटी एट एनी इंस्टेंट. किसी भी इंस्टेंट पर उसकी वेलोसिटी हम कैसे कैलकुलेट कर सकते हैं. ओके, नाउ हियर व्हेन वी आर throwing the object with the velocity u, it is making an angle of theta with the horizontal, then this velocity along the x-axis that remains constant, but the velocity along y-axis that changes, that is because of the gravity. Okay, now here in this case the initial velocity along x-axis and the final velocity along x-axis at any point will always remain constant, and that will be u cos theta. Now here I will consider any point where we have to find the resultant velocity at that point. Here this velocity along x-axis, that is equals to vx, and the velocity along y-axis I will consider vy. Here we have to find the resultant of these two velocities, and for that we have to find the velocity vx and vy, and these two are the final velocities. Now here this velocity vx, can I write this vx as u cos theta? Because the velocity along x-axis that remains constant, and the velocity along the y-axis that changes, because that velocity is changing because of the acceleration due to gravity. Okay, now here vx equals to u cos theta, but we have to find the value of vy, and this vy is the final velocity. So here we will use the first equation of motion, and that is for the velocity along y-axis. So I can write this vy is equals to uy plus ay into t, where v is equals to u plus at, and that is for the y-axis. Now this vy we have to find. I can write this vy as it is. This uy, that is the initial velocity along y-axis. The initial velocity along y-axis, that is equals to u sine theta. I can write here as u sine theta plus ay into t. Now at this point the acceleration due to gravity, that will be minus g. लेकिन यही acceleration due to gravity अगर हम h point के बाद में कहीं पर लेते तो कितना आता, plus g, because in that case the object is moving towards the surface of the earth. In that case it will be plus g, but before h point the object is moving in the upward direction, that's why its acceleration due to gravity will be negative. So here I can write this ay is equals to minus of g. Now this t, that t is the time in which the object is reaching from point A to this point, and this point is point P, and we'll consider that time to be t as it is. So I will write here as t. So I will write this vy is equals to u sine theta minus g t. So this is the final velocity along y-axis, and this is the final velocity along x-axis. Now here these two velocities, they are making an angle of 90 degree. Okay, so how we can find the resultant if we have two velocities or the two vectors which are acting at some angle? So here this resultant velocity v is equals to under root vx square plus vy square plus 2vx vy cos 90. Here the angle between vx and vy, that is equals to 90 degree, and cos 90, that is equals to 0. So I can write v is equals to root of vx square plus vy square. Okay, now I will put the value. V is equals to under root vx square, that is equals to u square cos square theta plus vy square, that is equals to u sine theta minus gt whole square. So I will write v is equals to under root u square cos square theta plus, I will open this bracket, that is a minus b whole square. It is a square minus 2 u gt sine theta plus g square t square. A square plus b square minus 2ab. So I will write v is equals to root of, here I will take u square as common, then there will be sine square theta plus cos square theta, and that will be equals to 1. So I will write u square plus g square t square minus 2u gt sine theta. So this is how we can find the resultant velocity. Now here this resultant velocity, that will be from the same point, because you can consider this vx and vy, they both are co-initial. और अगर यहाँ पर आप पैरेललोग्राम लॉ यूज करते हो तो इसके लिए जो रिजल्टेंट आएगा वो भी इसी पॉइंट से आएगा, एंड दिस विल बी v here. Okay, so this we have calculated the resultant velocity. Now here I will consider this angle to be alpha, because here this resultant velocity is making an angle of alpha with the velocity along x direction. Okay, so here we can also calculate the angle. So how we can calculate the angle? We have this tan alpha. Here tan alpha, that is equals to perpendicular upon base. Here this perpendicular, that is equals to Vy, and that base we have Vx. So I can write this Vy, that is equals to u sine theta minus gt divided by Vx. This Vx is equals to u cos theta. So with this we can also find the value of alpha, that is the angle of the resultant velocity with the x. Okay, so this is all about the velocity of the projectile at any instant in the case of projectile given angular projection.